As we look at these problems, remember that percentages are simply fractions based on hundredths. So the first problem is this: if the £15,000 car price is raised by 3% next month, how much more will it then be? 3% of 15,000 is 300ths times or of 15,000. That is to say, 0.03 times 15,000, which equals 450. So the car will cost £450 more next month. If the £15,000 car price is 10% lower, what will the new price be? 10% of 15,000 is 10 hundredths of 15,000, or 0.1 times 15,000, which equals 1,500. So the price reduction is 1,500. 15,000, the original price, minus the price reduction 1,500, gives the new price of 13,500. Alternatively, we could say the new price is 100 minus 10 equals 90%. So 90% of the original 15,000 price is 90 over 100 times 15,000, or 0.9 times 15,000, which equals £13,500. Here we want to find the full price of the £15,000 car if the £15,000 is before we've added 17.5% value added tax. Earlier we calculated the size of the increase in price. Here we want to find the new price. That is, the original price plus the increase. The neatest way to do this is to say that we have a scale factor of 100% of the old price plus 17.5% the increase in price. So 100 plus 17.5 is 117.5 over 100, that is to say 1.175. That's the scale factor. So the new price is the old price multiplied by the scale factor. 15,000 times 1.175 equals £17,625. Now what we want to know is, if the £15,000 car includes value-added tax already, what's the price of the car before the addition of VAT? If we want the price before the increase, we can use our scale factor. This time we divide by the scale factor. 15,000 divided by 1.175 gives £12,765.96. Notice we couldn't do this by reducing £15,000 by 17.5%. We needed the scale factor. In our final problem, we have a £15,000 car that's going to depreciate by 30% in the first year, and then depreciate a further 20% in the second year. We want to know the value of the car at the end of the second year. If we needed to know the second-hand value of the car at the end of each year, we would need several calculations. But if we only need to know the value at the end of the period, we can reduce the amount of calculation by multiplying the scale factors for each year, then using that as the reduction in value. The first year scale factor is 0.7. That's our 100% less the 30% depreciation. The second year scale factor will be 0.8. That is the 100% less the 20% depreciation in that year. So we now multiply those two scale factors together 0.8 times 0.7 gives us 0.56. So we have a £15,000 car times 0.56 gives us 8,400, the new value of the car after the 2-year depreciation. Note that we can't say 30 plus 20 equals a 50% depreciation, so that the car is now worth half the original, i.e. 7,500. We can't do that. That's because the 20% depreciation in year 2 is 20% of the value at the end of year 1, not 20% of the original 1,500. So there are several ways of doing such calculations involving fractions and decimals, but the use of scale factors is often the most efficient.